So now let's talk about the problem of the day. Remember, your job during this time is to participate by thinking, responding to questions out loud, and comparing what we talk about to how you approach the problem of the day. You're brilliant, and you might have a different way of representing and solving than I share. That doesn't mean your way is wrong, but you should be making sure it's accurate and clear by comparing your work to the work that we look at together now. So, how could we represent this problem of the day? Say it out loud. Yeah, one thing you might have said was use a table. Okay. Another, annotate on the picture we're given. Sure, we can do that. Some of you might have even said to actually keep drawing the picture. All right, let's try all of these. So, what happens between the first and the second story? Between the first and the second story. Say it out loud. Right. The number of blocks increases by 2. 1 block to 3 blocks. So in the first story, we had 1 block. In the second story, 3 blocks. Great. And what about between the second and the third story? Say it out loud. Yeah. Here, the number of blocks increases by 3. Right? Now we have 6 blocks. I'll put that in my story as well, or my table as well, excuse me. What do you notice about this pattern so far? Say it out loud. Yeah. The rule seems to be that we're increasing by 1 between each term. Interesting. So how would we figure out how many blocks go in the 4th story? Say it out loud. Okay, we'd add 4. Well, here was our first story, our second, our third, and now our 4th story, 10 blocks. Huh. What do you think? Does this make sense? How do you know? Say it out loud. Yeah, one of the nice things about geometric patterns is that we can see them. Not only does this make sense in terms of a rule that fits our previous terms, it also just looks right. Each story is adding a tower that is 1 more than the tower before it. So, how many blocks will it take for the 5th story? How do you know? Say it out loud. Yeah, 15 blocks. Because each time we're adding a tower that has 1 more block than the previous tower. So we're going to add a tower of 5. Let's draw our picture. And now a tower of 5. $15 blocks. Great. So, what was my rule here? Say it out loud. Yeah, the rule was each time you add a tower, you're adding a tower that has 1 more cube than the previous tower. With numbers, I'm going to write it like this. The rule equals +2, +3, +4, and then I'll put these 3 dots to show that that increase just keeps happening. Okay, So what strategies did we use to help figure out the rule for this pattern? Say it out loud. Sure. We drew a picture. We annotated the relationship between each term in the pattern. And we used a table to organize our information. So overall, how is this the same or different from what we've been doing with patterns in our previous lessons? Say it out loud. Yeah, we are still looking for the relationship between terms in the pattern to find a rule. But it's different because now the terms are shapes. We can see the pattern, not just calculate numbers. So then what thinking question do you think we can use to help ourselves today? Say it out loud. Yeah, you might have said that we could ask ourselves, how do these shapes relate to each other? It's the same thinking question we've been using, except now we're working with shapes, not numbers. Okay, one last question to make sure we're clear on something that might be confusing. How is this table here? How is it different than the in and out tables that we've been working with previously? Say it out loud. Yeah, we aren't putting in a number, applying a rule, and then getting a new number out. The rule here is between the number of blocks in the stories, not between an in and out number. So we went +2, +3, +4, +5. Again, the rule is between the blocks in the stories, not between an in and out number. Okay, click the arrow to move to the next slide.